On September 2, 1998, a McDonnell Douglas MD-11 operating as Swissair Flight 111 took off for New York's JFK Airport. It was a scheduled, completely routine flight heading to Geneva, Switzerland. But less than an hour and a half later, the aircraft crashed into the Atlantic Ocean just off the coast of Peggy's Cove, Nova Scotia. Tragically, all 229 passengers and crew members on board were lost. In this explainer, we're going to unpack the anatomy of this disaster. It remains one of the most complex cases in aviation history, and it triggered an absolutely unprecedented, incredibly demanding forensic investigation. So the central mystery investigators had to solve was, frankly, staggering. How does a seemingly minor everyday technical hiccup turn into a completely uncontrollable fire that dooms a highly sophisticated aircraft in a matter of minutes? At first, the flight crew just noticed a strange smell, and they reasonably assumed it was just an air conditioning issue, something pretty common. But as we're going to see, they were completely in the dark about what was actually raging just inches away from them. The key to unlocking this whole mystery is located right above the forward passenger cabin and the cockpit, in a concealed space we call the attic area. It's literally packed with structural framing, environmental ducts, and just massive, dense bundles of electrical wiring. And this is exactly where the catastrophic fire ignited. It was raging up there, entirely hidden from the flight crew working below. To really grasp how terrifyingly fast this happened, we've got to look at the timeline. At 0110 UTC, they noticed that strange smell. 4 minutes later, visible smoke. They immediately put out a pan-pan urgency call to air traffic control. By 0115, they make the call to divert to nearby Halifax. But then, things deteriorate so fast. At 0124, the fire starts tearing through critical systems, and the autopilot disconnects. A minute after that, all communications and secondary radar go dark. At 0131, literally just 20 minutes after they first noticed an odor, the plane hits the water. 20 minutes. That's all it took. You know, what makes this particularly heartbreaking is that this highly trained crew did exactly what their manuals told them to do. They started running through the standard smoke and fumes of unknown origin checklist. But there's a tragic irony in step 2, shutting off the cabin bus switch to cut electrical power. They had no way of knowing this, but flipping that switch had a devastating unintended consequence. It turned off the ceiling recirculation fans. Without those fans actively pushing air backward toward the tail, the airflow in the attic reversed. This sudden pressure change violently sucked the hidden fire forward, pulling it directly into the space right above the cockpit ceiling. Hitting the ocean at over 300 knots instantly shattered the aircraft. So to figure out what sparked that hidden fire, investigators literally had to put the plane back together. This kicked off Operation Persistence. It was an unprecedented recovery mission that would eventually pull over 2 million individual pieces of wreckage up from 55 meters down on the ocean floor. 2 million pieces of a giant, tragic puzzle. Just to wrap your head around the sheer scale of Operation Persistence, it was massive. It brought together 400 Air Force and 700 Army personnel from Canada, working side by side with local fishermen. The U.S. Navy even brought in the USS Grapple and its elite salvage divers, while a Canadian submarine used sonar to hunt for the black boxes. For 13 solid months, they painstakingly dredged and dove, ultimately sorting through an unbelievable 240 kilometers of electrical wire. Which brings us to an absolute forensic nightmare. You're standing in front of 2 million pieces of metal and plastic and 240 kilometers of twisted, saltwater-soaked wire. How on earth do you pinpoint the exact origin of a fire? It is the ultimate needle in a haystack. Investigators started hunting for tiny thermal clues. They looked for paint discoloration or the way plastic had melted, which told them the direction the heat was moving. And all those tiny clues pointed them squarely to the right side of the cockpit's rear wall. And right there, they found their ignition source. The whole breakthrough came down to a specific mechanism called electrical arcing. Basically, when the insulation around a wire gets damaged, electricity can jump or arc across the gap. This creates an incredibly intense localized blast of heat. We're talking hot enough to instantly melt copper. And amazingly, on a single segment of wire from the plane's in-flight entertainment network, investigators found a distinctive, tiny bead of resolidified copper. That tiny bead was the smoking gun. It was the spark. But here's the thing, a spark alone doesn't bring down a commercial airliner. It needs fuel. And this is where we uncover a massive regulatory failure. See, the aircraft's insulation blankets were wrapped in a material called MPET. Now, MPET was officially certified because it passed a vertical Bunsen burner test. The rule was if you expose it to a flame for 12 seconds and it just shrivels and shrinks away without catching fire, it's safe. But an electrical arc, that's an intense, continuous heat source. When investigators tested MPET against an actual electrical arc, it failed spectacularly. It didn't shrink away, it instantly ignited and acted like rapid kindling, feeding the fire. The realization they came to was absolutely chilling. As one expert bluntly put it in a Nova documentary about the investigation, when they looked at the burnt remains of those insulation blankets, the terrifying thought was, these things are flying fire traps. This is the tinder waiting for the match. Think about that. The ceiling of the aircraft was essentially packed with highly flammable fuel, and it was entirely approved under the safety regulations of the time. And it gets worse, because it wasn't just the insulation blankets acting as fuel. Once the MPET caught fire, it rapidly spread to totally mundane, everyday materials hidden up in the ceiling. Silicone end caps on the air conditioning ducts melted away, which basically pumped fresh oxygen right into the flames. Even simple hook and loop fasteners, Velcro, along with splicing tapes and barrier foams, they all acted as extra kindling. It allowed the fire to jump across structural gaps and rage entirely out of control. As devastating as the loss of Swissair Flight 111 was, it did not happen in vain. The incredibly exhaustive work by the Transportation Safety Board of Canada fundamentally changed the landscape of global aviation safety. Once they discovered just how lethal MPET really was, the FAA and global aviation authorities didn't hesitate. They issued immediate mandates to completely strip and remove MPET blankets from every single commercial aircraft worldwide. And the regulatory overhauls went way beyond just swapping out one bad material. That outdated Bunsen burner test completely scrapped. They replaced it with the highly rigorous radiant panel test, which demands pretty much a zero burn rate under real-world fire conditions. We also saw strict new standards put in place for electrical wiring. There's now intense oversight for secondary modifications, like putting in a new entertainment system. And crucially, emergency checklists were completely redesigned. Today, unknown smoke is never treated as just a minor nuisance. It demands immediate preparation for an emergency landing. There's no doubt that modern air travel is exponentially safer today directly because of the hard lessons learned from the wreckage pulled from the Atlantic. But as we wrap up this explainer, it leaves us with a pretty provocative question. As our technology gets more and more incredibly complex, are there still hidden vulnerabilities in the systems we trust the most, just waiting for the right spark? It seems that constant, unwavering vigilance is the true price of safety.
E.O.T.H. Investigations, formerly Echoes of the Horizon, where every flight leaves an echo behind.